Hello students and welcome to our class today. Today's class, I want us to start by looking at the determinant of a 2 by 2 matrix. A 2 by 2 matrix, first of all, it is a matrix that has got two rows and two columns. It's actually a matrix that is going to be of this form. If A, B, C, D are our elements for this particular matrix, it has got two rows. This is row number 1, this is row number 2. And it has got two columns such that this is column number 1 and this is column number 2, like that. So the two rows and the two columns, they make this one to be called the 2 by 2 matrix. When you are looking for the determinant of a 2 by 2 matrix, it is actually obtained by determinant, normally denoted as det, is actually given by the product of the main diagonal minus product of secondary diagonal. The difference between the product of the main diagonal and the product of the secondary diagonal is actually the determinant, where the diagonal that is running from the top left to the bottom right, this diagonal here, it is normally referred as the main. This is the main, or also referred as the leading diagonal. The other diagonal that is running from top right to bottom left, that is this diagonal here, it is normally the secondary or the second diagonal. This is the secondary diagonal. So when we say determinant is given by the product of the main diagonal minus the product of the second diagonal, in this case, the main diagonal being the elements A and D, it is going to be AD minus the product over the secondary diagonal, which is BC, like that. So the product simply means we multiply the two elements of the main diagonal, then we minus the multiplication or the product of the other diagonal. Let us have a numerical example. If you are given matrix B, always matrix is represented by a capital letter, is given by maybe 2, 4, and then 3, 9, like that. The determinant for this matrix is going to be the product of the main diagonal, which is 9 times 2, minus the product of the other elements in the secondary diagonal, which is 4 times 3. And you realize this one is going to be 18 minus 12, which is actually going to be 6, which is going to be 6. So if you are told that matrix C is given by -3, 4, and maybe 5, 0, and you are told to find the determinant in this case would be given by the product of the main diagonal, which is -3 and 0, minus the product of the secondary diagonal, which is actually 4 times 5, which gives you 0 minus 20. So the determinant is going to be -20. So basically, that is how we determine the determinant of a 2 by 2 matrix. Another very important concept that you need to understand when it comes to a 2 by 2 matrix, it is how do you determine the inverse of a matrix? How do you determine the inverse of a matrix? Inverse of a 2 by 2 matrix. A inverse of a matrix, like for example, if you are given A is equals to 2, 4, 3, 7, like that, and you are told find the inverse, which is normally denoted by power -1. If you find anything that is power -1, it is simply the inverse of this. If A is this, therefore A power -1 is the same as the inverse of the matrix A. In this case, the first thing, step 1, find determinant. Find the determinant. In this case, the determinant will be the product of the main diagonal, which is 2 times 7, minus the product of the secondary diagonal, which is going to be 4 times 3. In this case, it's going to be 14 minus 12, which is actually 2. That is actually the determinant. Then, after getting the determinant, you get now the inverse. The inverse is normally given by, this is now step 2. You interchange the elements. Interchange the elements in main diagonal and multiply the elements in main diagonal, in secondary diagonal rather, multiply the elements in the secondary diagonal by -1. Multiply the elements of the secondary diagonal by -1. In this case, what will happen? It's going to be, if we interchange this one, we are going to have 7 coming there and 2 coming down here. They interchange the position, and then this diagonal, or these elements in the secondary diagonal, we multiply them by -1 to change their sign. Actually, it's going to be -3 times -1 is going to be, 3 times -1 is going to be -3, and 4 times -1 is going to be -4. That is what we mean by this statement. You interchange these elements, and then this one you multiply by -1, or in short, you change their sign. If they were positive, they become negative. If they was negative, they become positive, like that. And then now, the last step is you multiply now what you have here by the reciprocal of the determinant. Multiply by 1 over determinant, which is actually the reciprocal. If you do that, you are going to find that this one is going to be 1 over 2, which is our determinant here, times now what you have there. Let us do a very quick one on the same. You are told B is equals to 4, -2, 3, 5. Now you are told find B power -1. B power -1 here, it is going to be, first of all, get the determinant, which is going to be 5 times 4, which is 20, minus 3 times -2, which is going to be -6, which is actually going to be 20 plus 6, which will be 26. That is the determinant. The other thing now you will be required to do is to multiply 1 over the determinant times, you interchange this one, so 5 will come there, 4 will come there. Then you multiply by -1 the elements in the secondary diagonal. So this one is going to be -3. And if you multiply by -1, this one is going to be +2. And actually, that is the inverse of the matrix B. As simple as that. You can go ahead and open the bracket, so that now this one is going to give you what? You can open the bracket. This one will give you 5 over 26, 2 over 26, -3 over 26, and 4 over 26. That is actually going to be the inverse, or you can leave it at that point, but it is preferred that you go up to the last stage, whereby you are supposed to get your elements in the inverse, being over the inverse, or divided by the inverse, or the determinant for that particular case. Now, having done that, now we can go ahead and see how can we solve simultaneous equations using matrix method. How do we solve simultaneous equations using matrix method? So one thing you realize is this. Simultaneous equations are those equations that have got more than one unknown. They have got more than one unknown, but we are going to deal with a case whereby we have got two unknowns because we are talking about 2 by 2 matrix. Because we are talking about 2 by 2 matrix. Let us consider this example where we are given the two equations, that is 5m plus 2n is equals to 19, and the other one is 3m minus 4n is equals to 1. And you are told you solve these two equations using the matrix method. The procedure is, number one, you change whatever we have on the left-hand side to be in matrix form. You write these numbers that we have here in matrix form. So we are going to have 5, 2, 3, negative 4, like that. And then the unknowns in this case is actually m and n. And then you say is equals to 19 and 1, like that. The next step is to find the inverse of this particular matrix, and we multiply that inverse on both sides. So the inverse of this, first of all, let us get the determinant of this matrix, which is going to be 5 times negative 4, which is actually negative 20, minus 3 times 2, which is 6, which is negative 26. That is the determinant. So the inverse is going to be 1 over negative 26 times 5, 2, 3, negative 4, like that. And this is actually what we need to multiply both sides of this particular matrix equation. So we are going to have negative 1 over 26 into 5, 2, 3, negative 4. You multiply by the original matrix that we had, which is 5, 2, so let us actually do it. At this point, I tend to believe we did not finish our inverse. Our inverse, we were supposed to interchange the elements in the main diagonal. Actually, at this point, we made an omission. We are supposed to interchange the elements, and the other one we multiply by the negative 1 so that we can have a complete inverse. So here, after getting the determinant is negative 26, we are supposed to come here and interchange these elements, which we are going to have negative 4 and 5 interchanging the position. And then this one we multiply by negative 1. Each of them is going to be negative 3 and negative 2. That is actually the inverse of that matrix. Then now this inverse is supposed to be multiplied both sides. So we are going to have negative 1 over 26 multiplied by negative 4, negative 2, negative 3, 5. We multiply by the original matrix, which is 5, 2, 3, negative 4, like that. Mn, which are now the unknowns, must be equal to this inverse. It must multiply both sides. So we are going to have negative 1 over 26 into negative 4, negative 2, negative 3, 5 times what we had on the other side, which is 19.1, like that. Having reached here, what you need to notice this. This is the inverse that was obtained from this matrix. This matrix gave us this inverse. One thing you should be able to remember at this point, the inverse of a matrix times the original matrix from where the inverse was obtained will give us what we call identity matrix. If we try to work out these two matrices, if we multiply them, we are going to find that we are going to have an identity matrix which is of that nature, and then we multiply by this one, which is Mn, should give us whatever we have on the other side. Let us multiply these matrices. If we have negative 4 and we multiply by 19, we are multiplying these two matrices Let us first of all leave our own negative 1 over 26. Let us multiply this row to multiply this column. Negative 4 times 19. Negative 4 times 19. It gives us negative 76 plus negative 2 minus 2 plus negative 2. It gives us negative 78. This times this plus this times this, we get it as negative 78. Then we have got negative 3 times 19. Negative 3 times 19, which is actually negative 57. Negative 57, negative 57, negative 57 plus 5, which is negative 52. Don't forget at that point we have negative 1 over 26, which was here. So anytime you multiply identity matrix times any matrix, it is actually the matrix itself. What you need to understand, this is like multiplying a matrix by 1. Whenever you multiply a number by 1, you get the same number. So mn times the identity matrix, you will still get mn. It is the same as multiplying 8 times 1, which is 8. It's the same as multiplying 100 times 1, which is 100. So a matrix times identity matrix, we get the matrix itself. And then now should it be equal to, if we open the bracket, let me work out negative 78 times negative 26. You find that it's going to give you negative 3, positive 3, sorry, positive 3, and this one is going to give you positive 2. So in short, m is equals to 3. You just equate direct. M is equals to 3, n is equals to 2. N is equals to 2. And actually that is the solution to that particular matrix. That is the solution to that particular matrix. We can have another example so that we can summarize that particular area where you are given this. You are given the two equation, that is x minus 15y is equals to 3 and 2x plus 3y is equals to 39, like that. You are told you use matrix method. As usual, start by arranging this one into matrix form. Remember, this is 1x, so you start by 1. This is negative 15. This is 2 and 3. You put them in matrix form. The unknowns in this is x and y. They should give us 339. You put everything in matrix form. Then get the inverse of this matrix, but first of all determine the determinant. 3 times 1 is 3 minus 2 times negative 15 is negative 30. So it's going to give us 3 plus 30, which is 33. So the inverse is going to be 1 over 33 into bracket 1 over 33 into bracket. Let these elements interchange. So we have 3, 1, and this one to change the sign. So it's going to be negative 2, and this one will be positive 15, like that. Then you multiply by the original matrix that was there, which is 1, negative 15, 2, 3 times xy, our unknowns. They should give us what? This must always start also. Make sure it starts on the other side. So we have 1 over 33 into 3, 15, negative 2, 1. The inverse, it must multiply each side and make sure it starts on each side. The same way it is appearing the first one here, it should also appear the first one here. And then we have 339, like that. Then you come here and you conclude. matrix times its inverse, it is identity matrix. And identity matrix times any matrix, you get that matrix again. So at the end of the day, if you do all this multiplication here, you are going to remain with xy. That is actually one thing you need to know. There's no need of going ahead and multiplying them. If you multiply this times this times this, you are going to remain with xy is equals to, let us work out this brackets first. 3 times 3 is 9. 15 times 39. 15 times 39, you get it as a 585 plus the 9, you get 594. I've just multiplied 3 times 3 is 9, and this times this, and then I add the 2. So you get the total is going to be 594. Then I come here, I multiply this, negative 2 times 3 is negative 6. Negative 6 plus 39, because 1 times 9, 1 times 39 is 39. So it is negative 6 plus 39, which gives you 33. And remember, everything was supposed to be multiplied by 1 over 33. So you will find at the end of the day, your xy will be given by 594 divided by 3, 33. You get it is going to give you 18. And 33 divided by 33 is 1. So the answer for x is 18 and y is 1. And if you substitute them here, you should get actually a proof that they are the correct answer. If you come here and you put x to be 18, so it's going to be 18 minus 15 times 1. Is it giving us 3, what we have here? Which is true. This is the same as 18 minus 15 is actually 3. So those answers are correct. Basically, that is how we use the matrix method to solve simultaneous equation. And that marks the end of our today's lesson. Thank you very much.